How are you everybody? How are you today? This is the fourth lecture in our course Mathematical Advanced or Advanced Mathematics. This is the fourth lecture for the fourth year statistics department in English section Benha University 2020. This is an important lecture about integration. Integration is a very important part in mathematics and statistics and all topics in life. So that this lecture may be very important to each student to know what is the meaning of integration, the basic of integration and steps of integration. Integration. The symbol of integration. Integration fx dx. This is the symbol. Every problem in integration must have this symbol. What is the meaning of integration? The identified integral of fx with respect to x, i.e. a function whose derivative is fx. Again, the symbol integral fx dx. The meaning, the indefinite integral of fx with respect to x, i.e. a function whose derivative is fx. Note that the integral sign dx acts like a pair of brackets around the function, just as a left-hand bracket has no meaning unless it's followed by a closing right-hand bracket. The integral sign cannot stand by itself, but needs dx to complete it. The integral sign tells us what operation to perform, and the dx tells us that the variable with respect to which we are integrating is x. Again, just as a left-hand side bracket has no meaning unless it's followed by a closing right-hand bracket, the integral sign cannot stand by itself but needs dx to complete it. The integral sign tells us what operation to perform, and the dx tells us that the variable with respect to which we are integrating is x. New term is antiderivative. Integration, antiderivative. Primitive function. Indefinite integral. Meaning, these are all different ways of saying. A function whose derivative is. Meaning, these are all different ways of saying a function whose derivative is. This booklet is intended for students who have never done integration before, or who have done it before but so long ago that they feel they have forgotten it all. Integration is used in dealing with two essential different types of problems. The first type are problems in which the derivative of a function or its rate of change or the slope of its graph is known, and we want to find the function. We are therefore required to reverse the process of differentiation. This reverse process is known as anti-differentiation, or finding a primitive function or finding an indefinite integral. And the second type are problems which involve adding up a very large number of very small quantities and then taking a limit at the size of the quantities approaches zero while the number of terms tends to infinity. This process leads to the definition of the definite integral. Definite integrals are used for finding area, volume, center of gravity, moment of inertia, work done by a force, and in many other applications. This unit will deal only with the problems of the first type, i.e. with indefinite integrals. Indefinite integrals. The second type of problem is dealt with introduction to integration part to the definite integral. This is part indefinite integral, and there is no any bound in definite integrals in the integral sign above or down the integral sign. But definite integral, there must be a bounded, there must be interval above and down the integral sign. What is the objectives of integration? By the time you have worked through this unit, you should be familiar with the definition of an indefinite integral as the result of the reserving the process of differentiation. This is the first thing you must learn about this chapter. Be familiar with the definition of an indefinite integral as the result of reversing the process of differentiation. Number 2, understand how rules of integration are worked out using the rules for differentiation in reverse. Understand how rules for integration are worked out using the rules for differentiation in reverse. Number 3, be able to find indefinite integrals of sums, differences, and constant multiplies of certain elementary functions. Be able to find indefinite integrals of sums, differences, and constant multiples of certain elementary functions. Be able to use the chain rule in reverse to find indefinite integrals of certain expressions involving composite function. It's very important, the chain rule. Be able to use the chain rule in reverse to find indefinite integrals of certain expressions involving composite functions. Be able to apply these techniques to problems in which the rate of change of a function is known and the function has to be found. Be able to apply these techniques to problem in which the rate of change is very important. The rate of change of a function is known and the function has to be found. We assume that you are familiar with the following elementary functions: polynomials, powers of x, and trigonometrics, exponential, and the natural logarithm function, and are able to differentiate this. We also assume that you can recognize composite functions and are familiar with the chain rule for differentiating them. In addition, you will need to know some simple trigonometrics identifies those based on the definition of tan, cosine, sine, and so on, and this based on the theorem These are covered in section in the mathematical learning. Okay. Other trigonometric identifiers are not needed for this booklet but will be needed in any course on integration. So if you are preparing for a course of integration, you should work through the whole trigonometric identifiers and as well as this booklet. Finally, knowledge of the inverse trigonometric function, sine, cosine, tan to the power minus 1, cosine to the power minus 1, sine to the power minus 1, and their derivatives would be a help but is not essential. Definition of the integral as an antiderivative. If d over dx fx f capital X equals small f x, then integral sine fx dx equal f capital X. If d over dx f capital X equal f small x, then integral sine fx dx equal f capital X. In words, if the derivative of f capital X is f small x, then we say that an indefinite integral of fx with respect to x is f capital X. For example, since the derivative with respect to x of x squared is 2x, we can say that an indefinite integral of 2x is x to the power 2. In simple, d over dx x to the power 2 equal 2x. So the integral sine 2x dx equal x to the power 2. Note that we say an indefinite integral, not the indefinite integral. This is because, note that we say an indefinite integral, not the indefinite integral. This is because the indefinite integral is not unique. In our example, notice that the derivative of x to the power 2 plus 3 is also 2x. So x to the power 2 plus 3 is another indefinite integral of 2x. In fact, if c is any constant, the derivative of x to the power 2 plus c is 2x, and so x to the power 2 plus c is an indefinite integral of 2x. It's very important and very easy to make this example. Now we express this in simple by writing integral sine 2x dx equal x squared plus c, where c is what we call an arbitrary constant. So we take the first capital letter c constant. This means that c has no specific value but can be given any value we like in particular problem. In this way we encapsulate all possible solution. We capture all possible solution to the problem of finding an indefinite integral of 2x in a single expression. In most cases, if you are asked to find an indefinite integral of a function, it is not necessary to add the constant plus c. However, these are cases in which it is essential, for example, in additional information is given and the specific function has to be found, or if the general solution of a differential equation is sought. You will learn about this later, so it is a good idea to get into the habit of adding the arbitrary constant every time, so that when it is really needed you don't forget it. The inverse relationship between differentiation and integration means that for every statement about differentiation we can write down a corresponding statement about integration. For example, d over dx x to the power 4 equal 4x to the power 3. So 4x to the power 3 plus dx equal x to the power 4 plus c. Vice versa. All these exercises I want from every student to check the understanding and solve every exercises very closely and understand the solution to check the understanding of the integration lecture. Thank you for everybody. Thank you for everybody. See you in the next lecture in the faculty and on the faculty website. Thank you for everybody.